Hi students, we are now beginning our study of Chapter 4, which covers human population. In this video, we will be covering sections 4.1 and sections 4.2 of the textbook. After studying this chapter, you should be able to answer the following questions. First, why are we concerned about human population growth? In this chapter, we'll learn that human population growth today is vastly different than it was before the Industrial Revolution. Second, you should be able to evaluate if the world's population might triple in our current century as it did in the last century. Lastly, you should be able to describe the relationship between population growth and environmental impact. In this chapter, we will also be covering some of the different perspectives on human population growth. Every second, on average, 4 or 5 children are born somewhere on the earth. In that same second, 1 or 2 other people die. This difference between births and deaths means a net gain of about 2.5 more humans per second on average in the world's population. In 2011, the United Nations announced that we had reached 7 billion people, having added the most recent billion in only 12 years. We're now growing at 1.13% per year. This means we're adding about 79 million more people to the planet every year. I placed a link in the soft chalk lesson. If you've not clicked it already, go back and briefly review this website, http://www.census.gov/popclock. Many people worry that overpopulation will cause, or perhaps already is causing, resource depletion and environmental degradation that threatens the ecological life support systems on which we all depend. Others believe that human ingenuity, technology, and enterprise can expand the world's carrying capacity and allow us to overcome any problems we might encounter. From this perspective, more people may be beneficial rather than disastrous. Whether human populations will continue to grow at present rates and what that growth would imply for environmental quality and human life are among the most central and pressing questions in environmental science. For most of our history, humans were not very numerous compared with many other species. Studies of hunting and gathering societies suggest that the total world population was probably only a few million people before the invention of agriculture and the domestication of animals around 10,000 years ago. The agricultural revolution produced a larger and more secure food supply and allowed the human population to grow, reaching perhaps 50 million people by 5000 BC. For thousands of years, the number of humans increased very slowly. Archaeological evidence and historical descriptions suggest that only about 300 million people were living in the 1st century AD. So what kept populations in check? In general, 3 things were responsible: disease, famine, and war. Many students do not realize that disease and infection were a constant source of illness and death. It was not until Louis Pasteur identified microorganisms as the cause of disease in the 1860s that people understood the germ theory of disease. Before that time, evil spirits, witches, and sleeping the wrong way were some of the many explanations for illness. Famine was also an ever-present threat. When the weather turned bad and prevented seeds from germinating or preventing crops from being harvested, or when fungus or pests destroyed crops, there was often very little of a backup plan available to feed a family or a village. Hunger and starvation were common. As you can see in the next slide, human populations began to increase rapidly after about 1600 AD. Many factors contributed to this rapid growth. Increased sailing and navigating skills stimulated commerce and communication among nations. Agricultural developments, better sources of power, and improved healthcare and hygiene also played a role. We are now in an exponential or J-curve pattern of growth, described in Chapter 3. It took all of human history to reach 1 billion people in 1800, but only 156 more years to get to 3 billion in 1960. It took us about 12 years to add the 7th billion. Another way to look at population growth is that the number of living humans tripled during the 20th century. Will it do so again in the 21st century? If it does, will we overshoot our environment's carrying capacity and experience a catastrophic dieback similar to those described in Chapter 3? As you will see later in this chapter, there is some evidence that population growth already is slowing. But whether we reach equilibrium soon enough and at a size that can be sustained over the long term remains a difficult but vital question. This slide shows human population levels throughout history. It is clear from the J-shaped growth curve that human population is growing exponentially. When will the growth curve assume an S shape and population level off? Given our current worldwide population projections, a global leveling is unlikely to occur this century. However, individual countries and regions do show stabilization. We will discuss the population growth rates of various regions later in this chapter. Many factors influence ideal family size. Level of urbanization, education levels, wealth, and a need for labor all contribute to creating the ideal family size for a given society, as we saw in the case study at the start of this chapter. If you have not read the case study in Chapter 4, please make sure you go back and review it. In urban industrialized countries, such as Brazil, most families now want only 1 or 2 children. How many children would you like to have? The number of children that families desire changes dramatically depending on the levels of education, levels of societal and economic development, religious and social belief systems, and available resources. There are many differing opinions about how this will all play out. There are 2 basic trains of thought about population. As we see in the next slide, some believe that population growth is the ultimate cause of poverty and environmental degradation. This belief was first described by Thomas Malthus. You may remember the character Scrooge from Charles Dickens' A Christmas Carol. Scrooge is a great example of this Malthusian philosophy. Scrooge believed that overpopulation is a critical issue and that having too many people will cause war and starvation, poverty, and environmental degradation. Therefore, it was beneficial to decrease the surplus population. In this worldview, population is to be closely monitored and controlled. Others argue that poverty, environmental degradation, and overpopulation are merely symptoms of deeper social and political factors. In this approach, the solution to population is social justice and empowerment. Overpopulation will end naturally given access to adequate resources. Which worldview we choose to believe will profoundly affect our approach to population issues. Since the time of the Industrial Revolution, when the world population began growing rapidly, individuals have argued about the causes and consequences of population growth. 2 opposing approaches to thinking about population were expressed in the 18th century in the works of Thomas Malthus and Karl Marx. In 1798, Thomas Malthus wrote an essay on the principle of population, changing the way European leaders thought about population growth. Malthus collected data to show that populations tended to increase at an exponential or compound rate, whereas food production either remained stable or increased only slowly. Eventually, he argued, human populations would outstrip their food supply and collapse into starvation, crime, and misery. He wrote, quote, "The superior power of population cannot be checked without producing misery or vice," unquote. The economist Karl Marx presented an opposing view. To him, population growth results from poverty, resource depletion, pollution, and other social ills. Slowing population growth, claimed Marx, requires that people be treated justly and that exploitation and oppression be eliminated from social arrangements. Both Marx and Malthus developed their theories about human population growth when the world, technology, and society were understood much differently from how they are today. Some believe that with our 7.3 billion humans, the Earth is approaching or may have already surpassed its carrying capacity. As we can tell by looking at the human population growth curve, time has proven Malthus incorrect, at least for now. One thing to keep in mind is that, to a great extent, the advances of the Industrial Revolution allowed us to very likely have dodged a bullet when it comes to famine, disease, and war predicted by Malthus. The question as we move towards a world population of 10 billion or more humans is whether Malthus will be proven correct, or if technology will again save us from massive depopulation owing to starvation, war, and disease. So if Malthus is to be ultimately proven correct, we need to answer this important question. Is the world overcrowded already? Or are people a resource? In large part, the answer depends on the kinds of resources we use and how we use them. It also depends on democracy, equity, and justice in our social systems. Some believe that we are approaching, or may have surpassed, the Earth's carrying capacity. Joel Cohen of Rockefeller University reviewed published estimates of the maximum human population size the planet can sustain. The estimates, spanning 300 years of thinking, converged on a median value of 10 to 12 billion. But that's a great number of humans, all drawing resources from the planet, and this could be disastrous. So if Dr. Cohen is correct, this sets the Earth's carrying capacity at somewhere between 10 to 12 billion humans. Given our current population of 7.3 billion and our growth rate of 1.1%, when do you think we might reach it? What do you think will happen when the number of humans surpasses the Earth's carrying capacity? If we do reach the Earth's carrying capacity, life on Earth could become very difficult. David Pimentel from Cornell University states that by 2100, if current trends continue, 12 billion miserable humans will suffer a difficult life on Earth. But this type of thinking has been seen before. Remember Malthus? But Malthus's predictions did not come true. Well, why was this? Well, it's because technology increases the carrying capacity of the Earth, at least to a point. The burst of world population growth that began 200 years ago was stimulated by scientific and industrial revolutions. Progress in agricultural productivity, engineering, information technology, commerce, medicine, sanitation, and other achievements in modern life have made it possible to support approximately 1,000 times as many people per unit area as it was 10,000 years ago. Optimists like economist Stephen Moore of the Cato Institute in Washington, D.C., regard this achievement as a real tribute to human ingenuity and our ability to innovate. There is no reason, he argues, to think that our ability to find technological solutions to our problems will diminish in the future. So on one hand, we have the Malthusian view, supported in current thought by the likes of Dr. Pimentel, and on the other hand, we have optimists like economist Stephen Moore, who believe that we will find technological solutions to our population and carrying capacity problems. To him, the answer to which approach is correct lies in our continued ability to find technological solutions. So how do we evaluate the impact of human populations on the planet? Our environmental effects aren't just a matter of sheer population size. They also depend on what kinds of resources we use and how we use them. This concept is summarized as the I equals PAT formula. It says that our environmental impacts, I, are the product of our population size, P, times affluence, A, and the technology, T, used to produce the goods and services we consume. While increased standards of living in Brazil have helped stabilize population, they also bring about higher technological impacts, for example. A family living an affluent lifestyle that depends on high levels of energy and material consumption and that produces excessive amounts of pollution could cause greater environmental damage than a whole village of hunters and gatherers or subsistence farmers. Put another way, if the billions of people in Asia, Africa, and Latin America were to reach the consumption now enjoyed by rich people in North America or Europe, using the same technology that provides that lifestyle today, the environmental effects will undoubtedly be disastrous. One way to estimate our environmental impacts is to express our consumption choices into the equivalent amount of land required to produce goods and services. This gives us a single number called our ecological footprint, which estimates the relative amount of bioproductive land required to support each of us. Services provided by nature make up a large proportion of our ecological footprint. For example, forests and grasslands store carbon, protect watershed, purify air and water, and provide wildlife habitat. If you have not had an opportunity to check your personal environmental footprint, you can go to the Global Footprint Network and calculate it. I have pasted the link into this slide. Population growth could, however, bring benefits. More people mean larger markets, more workers, and efficiencies of scale in mass production of goods. Moreover, adding people boosts human ingenuity and intelligence that can create new resources by finding new materials and discovering new ways of doing things. Economist Julian Simon, a champion of this rosy view of human history, believed that people are the ultimate resource, and that no evidence shows that pollution, crime, unemployment, crowding, the loss of species, or any other resource limitations will worsen with population growth. In summary, in this section, we have learned that population growth over the last 2 centuries is vastly different from the way that humans' populations grew in the past. With the advent of the Industrial Revolution, populations exploded and have been growing exponentially ever since. This gives rise to a concern that we have not yet entered a logistic growth phase that we are, or could very soon, exceed the carrying capacity of planet Earth.